that was the genesis of the silicon in India. And that's how they created that huge base. All the countries have realized that, gee, you are all depending on one country which could potentially be a strategic risk in some form. There's a larger scope of building a Indian alternative to Chinese chipsets. China, what it did in the 2000s is
Welcome to India Innovates, a podcast where we dive into the stories of innovators shaping the future from the heart of India. I'm Vaishnavi.
And I'm Shrinath. Together, we'll explore cutting-edge ideas and breakthrough technologies that are transforming communities, industries, and lives across the globe.
Whether it's a revolutionary startup, a pioneering researcher, or a visionary corporate leader, if they are innovating from India or for India, you'll hear about their stories here.
We'll also delve into the ecosystem that supports them, from the regulations and policies to the contributions of large companies that drive innovation at scale.
Let's uncover how India's unique environment is fostering a wave of creativity and ingenuity.
Hear stories of challenges, triumphs, and inspirations that have driven these changemakers to create and disrupt.
This is India Innovates, where innovation meets inspiration and India takes the center stage. Today, we welcome Sunil Kumar, the co-founder of BigEndian Semiconductors, a pioneering firm in fabless semiconductors.
Semiconductors are crucial for India's future, and we'll hear from Sunil about the process of developing one, the ecosystem it needs, and more.
Here's to more stories and experiences. Welcome Sunil Kumar to India Innovates.
Welcome, Mr. Sunil. You've been the co-founder and CEO at BigEndian Semiconductors.
Yes.
Welcome to India Innovates. Happy to have you today.
Thanks, Vaishnavi. Thanks, Srinath.
When we talk of semiconductors, most people think of either Intel or Qualcomm or ARM, but the industry is much larger. Why don't you just give us a view of how the semiconductor industry is structured?
The industry is much larger than what you hear the common terms on. I guess it's mostly related because of the employment opportunity it creates or the brand value it creates, the imprint it's created. But the far more bigger semiconductor companies than, in terms of impact, there's a company called ST Micro, there's a company called Western Digital, there's a company called Micron, which is in the news recently, Broadcom, Marvell Semiconductor, Cypress, you name it. Anything you touch today, right from your watch to your remote control to your television to your mixie to a washing machine, probably has a semiconductor in it. So not one company is supplying all of them. Right from the core of the application to the simple things like display or color or just management of on-off is done by a semiconductor. For that matter, even your disco lights in a festival are managed by a 16-bit controller or 8-bit controller. So there are semiconductors almost everywhere, just that we don't see it on a day-to-day basis. Yes.
The whole semiconductor, in fact, Silicon Valley itself started, the name got because of the many semiconductors companies that originated out of that.
Right.
So generally, how you've been in the industry for so long, could you illustrate how did it then move out of that? What movement was it about? And then slowly it found its way to countries like India and a couple of them more, so that it almost started now becoming that it is a superpower for few of the countries.
Correct.
Or it is on its way, like how we are
It's one of the
considering.
most critical things that most countries are talking about.
Yeah,
Yeah,
At least for the next year.
Next couple
decade.
of decades, wanting to own that piece of self-sustainability in semiconductors.
True. Yeah, I think Silicon Valley trumped out because of, again, nothing to do with Trump, but kind of came into being with, it's a perfect tsunami which happened at that time. We're talking about pre-60s, 70s, 65, 70 time frame, when people were trying to do more faster processing power on a device. Forget about computer, but on a device. So people were looking at, I don't know if you remember the old transistors or you remember the old radios, which had that analog transistor.
Vacuum tube.
Yeah, vacuum tube. It's a transistor fundamentally. You're just matching one voltage to another so that it's in sync and therefore the audio passes through. So people are looking at digital transistors and therefore what is the next big innovation? So I don't know if you remember a company called Fairchild Semiconductors. It was named something else before, just before that. They came out with an innovation at that time called microcontroller.
What year was it approximately?
It's 1967, 67, 70-ish.
So 60s and 70s generally was the era for the semiconductor.
Heavy, huge investment in physics and electronics to create new path-breaking, low power, low cost, high volume solutions. So everybody jumped into it, and the reason why Silicon Valley came into being is because because of Stanford, Berkeley, and the existence of previous other companies like HP. They were doing, HP was never a computer company. They were doing, they were a measurement company.
Yeah, yeah.
HP used to make measurement tools, actually.
In fact, I don't know if this is accurate, but Steve Jobs made a call either to Intel or HP to lend the first set of semiconductors, right?
Intel.
Intel,
Yeah.
Intel.
So Intel came after HP, but
Correct.
yeah.
So HP used to make precision, so-called measurement scales or instruments at the time. It's mostly analog instruments. So by and large, the innovation ended up being in Bay Area anyways. Just that when Bob Noyce, Gordon, all these Intel founders came into being, then they started saying, oh, you need a silicon, and therefore everybody jumped into it. And you know how, just like how our startup ecosystem is, even in 70s, I guess, so everybody jumped into semiconductors. So Intel was obviously having its own copyrights or slash patents on that microprocessor. They took the lead. A lot of money came into being. You also must have heard of something called a Sandhill Road, where most of the VCs, even today, are. So the whole money
As an ecosystem.
flow ecosystem started happening at that time. Xerox was just a stone throw away at that time. It was in Portland and in Bay Area. So ultimately, the whole Silicon Valley thing came. Though I personally don't like Bollywood as a copy of Hollywood. So I think by nature, I think in India, thanks to TI, is when the services industry picked up here.
Yeah.
Bobby
TI
Mitra,
was the
so I
first
don't know if you remember Bobby Mitra
Yeah.
is called. He was the guy who actually convinced his head office, saying that something called an ODC, that I don't think even the term existed. He said, can we do it in India? I believe there is talent. And hats off to that man, because wherever he is, he took that leap of faith and people supported him. And first TI Center came in, and that was the genesis of the silicon in India. And people started realizing that, yeah, these people have talent. So I think Silicon Valley of India became in India because of TI.
What year was this? From
This was in the
how many
80s.
years?
In India, it was
1984.
yeah,
so
84. Yeah,
84.
yeah.
They're much smaller. So I used to work for TI, so I know some of the history. Yeah.
It's almost 20
Much-
years
Yeah, yeah. It was
to
much
come to
smaller.
India.
Yeah.
Even to see
Around
the
15, 20 years.
15, 20 years.
But I think it was fairly fast, I should say,
Yeah.
because of, I would say, pure talent that TI had of Indian origin people. There must have been that gumption for Bobby Mitra to say, let's put this in India.
And I remember in TI we used to do a lot of global work.
Yeah.
It was not outsourced work that, low cost, they can't do it
Yeah.
there. Pretty much it was in
Yeah.
sync with the...
That's what I mean. That model even didn't exist at the time that
Yeah.
it is ODC,
Or as
labor
they call
arbitrage,
it-
nothing.
Or as they call it, Global Capability Center.
Correct.
Right? And TI was one of the
Back
Yeah,
in
it is just-
80.
Well, the term didn't exist, but
90s.
yeah.
It's just one of the office instead of Texas. There was one office in Bangalore. That's how you should look at it.
Yeah.
Wonderful.
But after that, it's grown to having quite a few majors. And I think the semiconductor industry itself is booming. What's the size of the semiconductor industry today?
Yeah, so semicon industry, the CAGR doesn't look that big compared to the CAGRs which we're used to in the traditional industry. But anything above 5%, I would say, is a great history, because the base you're talking about is about 500 billion. So semicon industry goes through a lot of these cycles. I think from 1990 to now, maybe about 35 years, you've seen almost 7 cycles of ups and downs.
Okay.
This year is a good year. Much better than the same quarter if you look at all other years. It's about $588 billion.
From a consumption point of view or from a...
Purely from sales outcome,
outcomes.
from
Right.
revenues
Right.
perspective. The collective revenues are about close to 600 billion. So 588 is what it might clock. So that's the size of the business. It was down last year. I mean, usually semiconductor industry goes through that cycle of up and down. But yeah, the winds are changing. I'm sure you gentlemen, you know what each country is trying to do with regards to semiconductor independence or self-reliance about creating their own technology roadmap. So
Right.
I think most countries also realize that it's important for national security to have
Some of these
establishment of
included in their own agenda.
Yeah.
So what's your background like? What's your journey been like? How did you come about Big Indian Semiconductors?
yeah. So my background, I've started. I mean, there's a degree called MBA, but I quickly realized probably my passion didn't lie in what you gentlemen, you people do. I mean, that never appealed to me. So I started liking more of technology, product management, and so on and so forth. So I started in those areas, and I was, like Steve Jobs says, it just happened. The dots just connected backwards. I didn't actually plan that way. So I started in GSM, and GSM was new here. GSM was one step away ahead of US analog DAMs those days. Then from there, I went to I don't know if you know these terminologies, but IS-95 based CDMA.
So these are all.
CDMAs were.
Yeah, these are all.
I know the CDMAs from the Reliance phones.
No, it was much before that. It's called.
DSL
I
is a
know
basic
it only
technology, yeah.
then. I think it became a household name. CDMA phones.
Different
right?
ways of for the telecom.
Correct.
Telecom ways.
So it's about how the best way to understand is how good is it spatially efficient.
Okay.
How much can you
Pack in
simultaneously? Yeah, given the airwaves that you have,
Yeah.
how many conversations can you hold? At that time, it used to be conversations. Now, because it's data.
Data.
Now it's far different.
Correct. So then I went to CDMA, which was the latest and greatest, and Tata was the globe's first IS-95 based CDMA in the country. So that's a great experience. Then I started started working like a drug to me. I mean, I started enjoying it. Then I went backwards and backwards. I went into embedded systems. Embedded systems may not mean much now, but those days when everything was non-IP, you needed to have boxes for everything. So you need to have protocol converters. You needed to have basically it's changing signal from let's say you're calling from a landline to a VoIP phone. How do you do it?
Yeah.
So somebody's converting it there, right? Like PSTN to IP, IP to PSTN, kind of a thing.
So when did your entrepreneur journey start?
A bunch of my wingmates from IIT, we started a SaaS company called Zenoti. It is now valued about $3 billion. That is my beginning of accidental entrepreneurship. I exited after Series C funding. Then I was largely, because I still, deep down, I felt I'm still a techie guy and not a salesperson. So I started investing small token investments into technology startups. But when this whole Make in India and the geopolitical environment started changing, I decided that let's find a problem which we can solve.
Okay.
And that's how Big Indian Semiconductors came into being.
So I'm sure most of us don't know the entire process of what it takes to build semiconductors, right? Well, policy-wise, we might all say, yes, we need to do it. What does it take if you have to build a startup or a semiconductor from India?
There are startups, and then I would say there are semicon startups. Semicon startup takes a hell lot of money upfront, even before you see even one piece of code working in action.
So if I had to just pause you here, right? The moment you say semicon startup, everyone assumes that you're going to build a fabrication center and you're going to produce a chip,
Okay.
right? But there's a lot that goes behind even before you get to that stage. And not every startup needs to make that chip because you have outsourced manufacturers for the production itself. But can you just help everyone understand what is that entire chain?
Okay.
For that?
So maybe I should back up, I guess. So if you look at the value chain of semiconductors, there is a fabless and a fab company. There actually in this globe there are only 3 companies which have their own factories, which means their own manufacturing capabilities of their own. One is Intel, another is TI, the third one is Samsung.
Okay.
By and large, I mean there is 1 or 2 companies here and there, but by and large these are the only companies have the latest and greatest of, which means they do end to end. That's how we need to understand. But is it efficient for everyone to put in a factory? It doesn't.
Okay.
So down the line, it's the best example is clothing industry. Does everyone who wants to wear a piece of suit, does he set up a tailoring shop? No. You go to a tailoring shop to get your suit stitched.
Or even brands offshore their
Absolutely.
Yeah, so you do the design, you do all of that
buying houses
elsewhere.
That is the fabless model, wherein you decide your input, you decide your architecture, aka design, you decide when, what, how, and then give the blueprint to the fabs for them to manufacture.
Okay.
So simply said, but even in this fab itself, there are fabs which do 4 nanometer, 7 nanometer. You must have heard these terms
TSMC also.
Yeah, TSMC.
Yeah. Many of them do.
Largely TSMC is on the leading edge.
Yeah.
So they do 4, 7, 10 nanometer.
So
fab.
what is your configuration like? What's your brand? What does Big Indian Semiconductor
So we are building a surveillance semiconductor made in India for the globe. So that's the objective.
So then your chips or your semiconductors would be used by surveillance companies?
Yeah, semiconductors would be used by OEMs who build surveillance cameras
Surveillance cameras, yeah.
for the end customer. So the beauty or the good or bad of semiconductors is we never end up meeting the end customer. Our customer is maybe Honeywell or Bosch. So I need to build a camera chip which has an output, which has an input. Now the input is any natural medium is analog, right? You're taking the picture and then digitizing it, which means there's an encoder, there's a decoder, then you're capturing voice, so there's a voice encoder, vocoder, voice codec or vocoder. Then there is something which is streaming or compressing them into the right algorithm to pump it out somewhere. So all these pieces exist in a chip. So you need to package it in a way it takes the least amount of area. Otherwise, if it's too wide, it is costly chip, and maybe Srinath won't buy it, or maybe Vaishnavi will buy it.
So
But
you have lines of facilitation to configure and produce this chips at your company.
to put these things in the most compact manner takes that much time. Unfortunately, it takes, to give you rough metrics, the design tools themselves might cost a couple of $1 million.
Okay.
The intellectual property, because you don't reinvent something which is already made. For example, if I'm putting a USB 3.0, nobody goes and says, I will build the USB 3.0 interface myself.
So
It's
I
like when you're building a house,
Uh-huh.
you don't build a window by yourself. You go and buy the window and fix it.
What's the innovation arc that your company in specific or you've done in the last couple of years?
If you were in a semiconductor industry, which is largely what is the cycle? We take about 6 to 9 months to design the chip. Chip goes to a factory like any other tailor. He takes that 3 months time for the fitting to be done. You take the fitting. If you really like it, then we call it finalization. That finalization takes about 6 months. In our words, finalization is something called an ESD testing. You know, if it is automotive grade, you need to have plastic which doesn't melt in a car, for example, right? A lot of fuels coming in, fumes. If you put a regular plastic, it'll not stay for next 5 years. So there are grades of chipset. It's called production ready chipset. So that cycle takes that 2 years, end to end.
Okay.
It's not like we are doing all 2 years we are designing a chip. So the cycles, because then there's a mapping we need to do. It'll be a little shocking for you that for the production chip, there are chipsets we run for almost 6 months continuously.
Okay.
It's called the testing phase, which we do, because we don't want these chips, if you are signing up on some guarantee that they are failing on the field. And let's assume that you are a military buyer for defense.
Yeah.
You just can't expect it to fail. So we know how to, only based on testing, real testing. It's like every other automotive testing.
So, for example, if you take, it's a good example you give of the car, right? The car has so many parts to it. A lot of it is electronic. But the car can be, minus 10 degrees in Ladakh, it can be 50 degrees in Rajasthan. The chip still has to function. And these are electronic items. Sometimes they stop, or the performance decays when you're in very cold, very hot environments. So you need to run all those tests and make that accurate. But as consumers, we also sort of look at semiconductors and say, every year when I buy a new phone, they're promising me that my performance is better. So the cycle is actually 1 year, 1 year.
Right.
Because we've sort of conditioned to see it that way. Every time I buy a new laptop, you're saying, hey, this is better than last year, better than last year.
Right.
But for a lot of other industries, that doesn't happen. You really don't want to change because the semiconductor chipset is at the heart of what you do. You might not want to change it very often. So once you build something, and if you get the right market
mix,
fit, it probably will last for 10 years.
Correct.
Right? Without changes.
Absolutely.
You might change everything around it. You might get a better surveillance. I'm assuming you'll probably get a better camera.
Yeah.
But you wouldn't change the chipset.
Absolutely.
So when you're designing your chipset, you're coming back and saying, 10 years from now, what sort of cameras will you have?
Right.
And how could I get that here?
So we look at the product life cycle innovation in the sense, there's a wave, right? If there is a 4 megapixel camera, how long will it last and what's the next wave? So it's like, to see how the chipset works, you need to have the ecosystem also that is building out.
Right.
If you don't, then you become Elon Musk and say, I will go and buy the lithium mines. For example, if you think that going forward, the phone will look like a camera and it'll just have some voice, then you need to go and figure out which is that biggest sensor you might get for a phone. So if you don't have the sensor, then I need to go to vendors or partners to say, hey, I need a sensor this big because I see the trends that selfie is the way to go forward. I'm just...
Yeah, so it's essentially you're looking at customer of customer, maybe 2-3 levels down before you build your roadmap,
Right.
which is why it gets a lot more difficult when it comes to semiconductors. And I think that's why also, while it is critical, it's not the easiest of things to do.
You could go completely wrong as well. So,
So what's the urgency for these innovations if it is going to take this kind of a timeline, or even if the build of it is going to sustain for a long period of time? How frequent, or what's the kind of urgency that, do you even have that kind of a innovation wave that needs to come, or as you put in early in the podcast, that it's a product development kind of cycle?
Yeah, certain paradigms have changed, even from beyond my gray hair. I think the paradigm has completely shifted in the last 10 years, for sure. Your dependency on your technology, dependency on your data, and therefore the security, privacy, and other impact that it creates is far, far more global.
Right.
So to your question, why the urgency now is, come COVID, when the dependency on this data and bandwidth and cloud became so obvious, all the countries have realized that, you are all depending on one country, which could potentially be a strategic risk in some form. India has a different perceived risk, I guess. Maybe US has different type of perceived risk. So all countries came to that realization while that
Okay.
calling was always on the cards. So if you look at India per se, we electronics is the second largest importer after petroleum, gold,
Okay.
etc., etc. Right? Gold is diamonds are largely imported because it's re-exported, so I'm not counting that. But
Yeah.
electronics do become a huge import. We import close to about 80 to 90 billion dollars year on year, and no amount of push from the government is helping that reduction in that import. What it means is you're still importing those chips while you might be adding value or low level value here. You're still ending up importing them.
Importing them.
That's what it means. The day that 90 becomes 45, it obviously means you're producing those chipsets here.
Okay.
Yeah.
Yeah.
Right.
Yeah.
So that is not, at even the COVID upturn, downturn has never stopped that growth. So governments realize that while we are the largest consumption market, highest amount of mobile phones, fastest growing automotive industry, two-wheeler industry, you name it, every
Yeah,
metric
yeah.
of regular consumption, hearables, wearables, number of email accounts, cloud-based, any metric you look at, we score out. Which means everywhere there's semiconductors and your dependency on your partners whom you feel there's a threat or risk increases.
Okay.
So I think while we have been always telling this to the industry people, I think there has been some change in the strategic outlook, and they started making the right push. I think it's a push in the right direction. It's not necessarily the complete push that you need. You need far more push than what it is. Like I mentioned, if you want to get even to step back, if BigEndian was a US company doing the same thing as we're doing right now, we would have raised at least 10 times more money than what we raised today here. So raising or the investors to take that risk on semiconductors in India is fairly low. Because we don't understand the business cycles. We don't understand why does it take an engineer of 15 years and why is he being paid so much to build that
No,
chipset.
we do have a lot of engineers
Yeah.
from the semiconductor.
Yeah, we form about 20 to 25% of global semiconductor engineering workforce. Yet there are not many semiconductor startups in India, and rightly, probably the reasons being what you said. And I think that brings us to the thing how other countries have developed. China in the late 90s and early 2000s, this disproportionate risk cannot be taken by a retail investor. I'm calling VC also as a retail investor.
Exactly.
So, can we not have this China plus one strategy ever in India because simply we don't understand the
No, we do understand. We completely understand. But India is caught in a democratic push-pull of should I do good for the general citizens or should I put a disproportionate amount of money?
So
on
prioritization
and
okay.
there everybody has. I think there's politics and there is strategy.
Yeah, but I'm curious, what did China do?
China, what it did in the 2000s is it went ahead and said, I will fund any semiconductor company which comes, which gives me a proposal. And it's not a
So the government funded.
government funded because government could take that risk.
Okay.
And it had a different viewpoint of creating this economy, which is, let's assume I do not take a protracted amount of time of evaluating any proposal. I put, instead of giving 100 million to one company, they gave 1 million to 100 companies in some sense.
Okay.
Yeah.
So what it did was, it cut the cycle time, and lo and behold, 1 out of the 100 anyway succeeded. And that's how they created that huge base, not just semiconductors, manufacturing, IP, OEMs, you name it. So they control the entire value chain of
Manufacturing.
electronics and system design
From end
industry.
to end.
Because suddenly you had so much of talent.
Yes.
So India has the talent.
Yes.
What we need is a little bit of capital which
Yeah,
will encourage.
that catalyzing investment from a regulator looking at the impact on the overall economy. Guess what happens? I mean, you hear the name Shenzhen and
Yeah.
Shanghai and all of that. Because Shenzhen developed so big, you have all the peripheral industries developing around it.
So I just want to come back again. When you could do many things, why did you choose surveillance markets as one of your focus areas?
There are just 2-3 reasons. One is, number one, there is a huge local domestic consumption in India itself. We consume close to about $4 billion worth of surveillance equipment. Out of that, $2 billion will be the cameras, and rest is equipment like recorders and cables and so on and so forth. So that's a huge consumption market. The second most important thing for us was surveillance suddenly became a very strategically important domain. US banned it, US banned Chinese chipsets, Australia banned, UK banned it. So what it means is there's a larger scope of building a Indian alternative to Chinese chipsets.
That comes to a China plus one.
Correct. That is the China plus one strategy we went with. And the third biggest thing was because of the way the industry was laid out for the last 20 years, dominated by Chinese, nobody had the will. Already, like Srinath was saying about investors not willing to come forward if there is no ROI for them. There was even more lower ROI in the surveillance side, and nobody innovated on that. Okay, we are still working on the decadic NVR, DBR based systems. Nobody switched over to cloud and things like that. So that's when we thought we can come and build that innovation cycle in a holistic approach. So that was the reason for coming to surveillance.
So earlier you had mentioned that retail VCs may not take such a plunge investing and waiting for such long periods in semiconductors. So what is your path? What's your relationship with funds and investing look like?
So we probably are a little lucky, and probably also because we are at that, I wouldn't say age, but maturity levels wherein we could build it in a more capital efficient manner. We raised little amount of money, which is still okay, but probably for a lot more startups it would be difficult. We just are relying on our ability that we have built several other chipsets before, and we had a good execution background. And that is what we are relying on. And it's not necessarily because we got the huge money. It's just that the founders came with that 100+ years of experience. Then we said we'll leverage that as a sweat equity into it, and therefore I won't need that much of
So
money.
if there is so much of a drive for being semiconductor independent and all that, what does the government grants look like? What's the kind of ecosystem you have from the government side to be able to set up fabrication units, to have the end-to-end setup infrastructure that you were earlier on speaking about? Where is, from a government point, where is that
What are the
support
incentives?
ecosystem and incentives headed to?
For a country like ours, I think it's a right start. They do have a decent level of incentives. They have created incentive scheme for fabrication units. So you must have heard about Micron building a OSAT company, Tata Microelectronics trying to put up a fab.
Somewhere in Assam, yeah.
Somewhere in Assam, and the office is in Bangalore, incidentally, in Sarjapur Road. Then there is, I hear that Adani is getting into it, Reliance is getting into it. I don't know. Because this takes about $10 to $15 billion to set up a fab.
Okay.
That's a lot of money.
China did pour in that kind of money, and that's how you have all the USMC and all of those companies in China, right? So anyways, so there is the fab part of it, which is a huge capex intensive. It's like building a dam. It's building like a power plant. Then you need to have the downstream stuff, which is semiconductor companies. Then you need to have manufacturing companies. So semiconductor design, manufacture, and then build a product around it, like a Wi-Fi router or something. So you need all three to coexist.
Okay.
So we come in the middle. So there is an incentive scheme called as a design-linked incentive, which is fairly decent. But the only sad part in that is it's a post-expenditure incentive,
Okay.
which means the burden of raising that level of money is still on me. If I do spend X amount of money, government gives Y amount of rebates back.
Right.
But it's not too bad. I think it's a great beginning. But we need to do a lot more. I mean, for a country of our size, I think we need to have maybe 100 companies coming all across, not just one or two companies.
Given that there's growing awareness and there is a lot of momentum, I think it's a space ripe for disruption right now. We might see more companies coming in. Right?
I totally agree with you. I think this is the decade, I believe strongly that this is the decade of semiconductors. And I think this is the decade of semiconductors in India as well. These two I genuinely believe in, because the way I see it is, my vintage people who could be in the 40s and 50s, who have seen the cycles of the entire semiconductor industry, work in the US or anywhere else, US, India, they have that maturity levels, like how we are drawing in from that maturity, to come back and do something either here or there, doesn't matter where. But
So
I think sure.
on that note, what do you think your advice would be to grads from IITs and who are starting to innovate in this space?
And all other colleges.
And all other colleges.
Not necessarily. Actually, these days, I don't see any focus spread like how it used to be before. Definitely not. I find everybody's has the same fire in the belly. But having said that, I believe in two things which I think we fundamentally are not doing right. And at least this is the only advice I give, because being part of somebody's success is good. Helping them succeed is good. Number one is defining the problem well.
Okay.
So we end up saying, I'll build this because I can, is not the right approach. You need to define the problem well. I feel the best defined problems get the best solution. So most often what we do is, hey, I'm an analog designer, so I'll build some power management solution. But think through, why do you want to build it? What's the problem that I'm solving? I think that's number one. Number two, biggest challenge I feel is, we are deep down engineers at heart, including me, deep down. But I think the biggest thing we need to cross that hurdle is put that away and say, let's assume I have that analog thing. How do I market it? Who's my buyer? Who's my system integrator? Like how Srinath was telling the whole ecosystem before. Who will be my end user and why will he buy my solution based on my chipset as opposed to already existing solutions? Or why would that OEM prefer my unit to make at least 20% of his entire portfolio? What is that I've got? So I think these are the two questions people need to answer. But more often, I find that, okay, hey, we build this XYZ solution. Why? No, we have experience in that. But that's not a good enough answer. And that's, I think, also the reason to Srinath's point earlier, that already a risk averse why should a VC take a risk already in a nascent area when the definition itself is not right?
Yeah.
But some of it is beginning to change.
Yes,
And I
of course,
think
of course.
A lot will change over the coming years.
Yeah.
And
So,
thank you for sharing your journey and insights on this industry.
Thanks.
And wonderful having you.
Same here, same here.
great having you, and I hope we have many more startups.
I
in
hope
the
so,
next
and
decade.
love to interact with any startups. If they have any issues, happy to be part of that ecosystem, always.
Thank you.
Thank
Yeah,
you.
thanks.